Hey class, this will be a Unit 2 review and test preparation. It's a pretty long test. The problems aren't super hard, but there are a lot of them, so buckle up. They're asking us to use the associative property, which is the buddy property or the hug it out property, to help solve this problem. So you're looking for numbers that are compatible. So when I see this, I'm looking at the first numbers I see are these two numbers. They're compatible numbers. So I'm going to go ahead and group those together, 1.5 and 3.5. There, that is an easy number to add in my head. That's 5, and then I just add the 177 to that to get an answer of 6.77, or 6 and 77/100ths. So look for numbers that are compatible. Problem number 2 is exactly the same. We're looking for compatible numbers, so I'm going to regroup them. These two numbers are friendly numbers, and 0.85 and 0.15 equals 1 whole. So I just add it like that, regroup. 7, 4, and 1 makes 12. So I have 12 here, and then I'm going to add the 5.69 to get 17 and 69/100ths. Select the numbers in which the digit 8 is 10 times the value of the 8 in 6.18. So I've drawn a place value chart, 6.18. I have 8/100ths. So 10 times 8/100ths would be 8/10ths. So I'm looking for any of these numbers that have an 8 in the tenths place would be a correct answer. So I see one here, so that's a correct answer. This is not correct. This is correct, 6.811. That is a correct answer. This is not, the 8 is in the hundredths place, so that's not 10 times greater. This time the 8 is in the tens place, that's not 10 times greater. And this is 8 in the ones place, that's not 10 times greater. So you're looking for a number that has a digit in the tenths place, because 8/10ths is 10 times greater, because you're moving one space over, than 8/100ths. In this problem they're asking us to make a number where the digit 3 is 1/10th the value of the digit 3 in 8.235, or 8 and 235 thousandths. So here we see the digit 3 is in the hundredths place here, so we're looking for a number that's 10 times less than or 1/10 as much, so that means it's going to be in this column here. So if I move the 3 over here, that becomes 10 times less than 3/100ths. It would be 3/1000ths. So any number you make would have the 3 in the thousandths place. So you could make a variety of numbers. You could put, as long as the 3 is in this place, you're fine. So you could make any other number here. It could be 5.823 or 8.523. It doesn't really matter as long as you have the 3 in the thousandths place. Question 5 asks us to write 357 and 904 thousandths in expanded form. So remember, expanded form is just taking the digit. So in this case, the digit 3, 300ths. So you just write 300 there, the value of each digit in each space, plus 50, plus 7, plus 9/10ths. Or you could just write as a fraction, plus 4 thousandths, and that would be expanded form. So standard form is just writing the number as you say it in the correct place value. They're asking us to enter 11,000 and 109 thousandths in standard form. So what you just write what you hear when you read it out loud to yourself. So here you have 11,000. So I'm just going to write 11,000, and is a decimal point right there, and 109 thousandths. So I have 11,000 here and 109 thousandths, and that's my and. Asking us to write the word form for this problem, 8. So you simply just write the number 8, and the decimal point is and, 8 and 36, and put a hyphen there, 8 and 36/100ths, because those are in the hundredths place. 8 36 and is the decimal point. John is not sure how to write 71 and 406 in expanded form using powers of 10. So there's two ways to do powers of 10. Think Central wants us to write it as just 10 like that. 1, 1/10, 1/100th, 1,000th. So that's what they want us to write, so they should enter that answer. But the smarter way to do it is 10 to the second power, 10 to the first power is 10, 10 to the 0 power is 1, 10 to the negative first power is 1/10, 10 to the negative second power is 100th, 10 to the negative third power is 1,000th. So I would write it the way Think Central wants, but you can also write it this way, like this. And here are the two ways that you could write it. This is the Think Central way, 7 times 10, plus 1 times 1, plus 4 times 1/10, plus 6 times 1,000th. Here's the intelligent way, 7 times 10 to the first power, plus 1 times 10 to the 0 power, plus 4 times 10 to the negative 1, plus 6 times 10 to the negative 3. Again, we got standard form, so you just write that number and put that digit where it belongs. That would be in the hundredths place. There's no tens here, so that would be in the ones place. Place value holder there. Get a decimal point. 6 would be in the tenths place, and there'd be nothing in the hundredths place, and you'd have 5 in the thousandths place. So the standard number would be 408 and 605 thousandths. Asking us to compare these two numbers, where is the digit 5 greater? Well, you can see in this first number, the digit 5 here is in the tenths place, so that's 5/10, and the digit 5 in the second number, even though there's no decimal point, it goes here. That's 25, that's 5 ones. 5 ones is greater than 5/10, so the value of digit 5 is greater in the number 25. Select the number that shows the digit 4 with a value of 400ths. So we're looking for any number that has a 4 in the hundredths place. So this one does, this one does, this does not, this one does not. The 4 is in the tens place, the 4 is in the tenths place, and there's no 4 in this one at all. So both those numbers have a 4 in the hundredths place. So those would be the answers. Asking us to compare these numbers, it's pretty obvious that 118 is greater than 2.158. Strategy here, just line up the dots, show me what you got. So if you line up the decimal points, you can see 118 is greater, so it is greater than. Make sure you're putting the symbol in the correct way. Comparing these two numbers, you see 0.9 or 9/10 and 0.90, 90 hundredths. Well, you can add a 0 to that, and those would be exactly the same. So these two numbers are equivalent. They're equal to each other. 0 is just a placeholder. So again, comparing these numbers, the way that I just write them out, I put them, line up the dots, and write the numbers. And you can see that this is 8/10 and this is 8/100, so 8/10 is greater than 8/100. Again, your answer is greater than. Again, comparing them, you have 1.354 and 984 thousandths. So you line them up, line up the dots, compare them, line up and compare, line up and compare. You can see that this has one hole and this has no hole, so 1 and 354 thousandths is greater than 984 thousandths. Question 16 is asking us to round this to the nearest whole number, and our holes are right here. These are our holes, so we're rounding it to this place. So the strategy on that is find the place you're rounding to, look to the right. If it's greater than 5 or greater, you round up. So this will round up. It is closer to 18 holes. Select the digit that show 4 and 97 thousandths rounded to the nearest hundredth. So we find the hundredths place, we look to the right, that is greater than 5, so that means we're going to round up. So that would round up to 10 because we have 9 there. But 10, if this is a 10, you regroup that over there. So the nearest hundredth here is actually 4.10 or 4 and 10 hundredths. This question is a multiple part question where they're asking us to round the same number to various places. So strategy here is find the place you're rounding to, look to the right, round up to that place, or round down. So if they ask us to round to the tenths place, we find the tenths, we look to the right, There's a number less than 5, so that number is just going to round to 134.8. It's going to round down. Rounding to the nearest hundreds, here's our hundreds right here. Look to the right, that's less than 5, so that number is just going to round to 100. 100 is closest to 134. Rounding to the nearest 1, here's our wholes right here. Look to the right, that's an 8, so that number is going to round up to 135 right there. Rounding to the nearest 10, here's our tens place. Look to the right, that is a 4, that is less than 5. So we're going to round that down to the nearest 10, which is going to be 130 tens, 13 tens. Our final one is round to the nearest hundredths. So here's our hundredths place. So look to the right. It's a 9. That's greater than 5. That means this is going to round up to 4. Fill in the blanks. 134 and 84 hundredths. Simple addition problem with decimals. Most important things, you line up the decimal points, draw your columns, and be very careful when you're adding. You have 5 hundredths and 8 hundredths. Gives you 13 hundredths. Regroup the 1/10 up there. 1/10, 2/10, 8/10 is 11 tenths. Regroup the whole here. 1 whole, 6 holes, and 3 holes is 10 holes. Regroup the 10 here. 1/10, 6/10s, 1/10 is 8/10s. No regrouping needed. 2 and 0 makes 2. So the answer will be 280.13 or 280 and 13 hundredths. Asking us to compare 5 and 52 hundredths and 4 and 83 hundredths. So you just need to be careful when you're regrouping. So you draw your columns. You don't have enough hundredths to take away 3 if you only have 2. So you regroup 1/10 into 10 hundredths. 12 minus 3 is 9. You don't have enough tenths to take away 8 if you only have 4. So you rename that as 4 wholes and 14 tenths. 14 minus 8 is 6. And 4 minus 4 is 0. So the difference is 69 hundredths. So in this problem, they're asking us to provide an estimate by rounding each number to the nearest whole. So what we're going to do is we're just going to round these numbers. 47.38 would round to 47 holes. 35.16 would round to 35 holes. So we are just going to subtract 35 from 47, giving us an estimated difference of 12 holes. Same as the last problem, we're going to estimate our sum. 22.76 would round up to 23 holes. 5.08 would round down to 5 holes. So you end up with 23 plus 5 to give us an estimated answer of 28. So that is the best estimate for this problem. So we're faced with a word problem, and with all word problems we want to do a meal, so we want to definitely think about using a model here. So I've drawn a picture of the park, and she runs around the park. Each time she runs, it's 305 and 87 hundredths. Now she's going to run around the park twice. So I'm going to do a part-part whole model. So I've drawn my part-part whole. I'm going to add these two numbers together to get my actual answer. Actual answer when adding these up is 611 and 74 hundredths. Now let's see if it's reasonable. I'm going to round each of these numbers to the nearest whole, which would be 306 and 306, and together the answer 306 and 306 would be 612. And as you can see, my actual answer of 611.74 is very close to 612, so my answer is reasonable. Alright, we're in a multi-step problem here. It's going to be a little bit difficult, so let's take our time to unpack this. Ray buys a skateboard for $89.88, a helmet for $34.74. It's tax-free, so you don't have to pay anything extra for tax, but they get a discount of $17.50 for both items. Ray gives the clerk $160. How much change does he get? So let's first draw a model to represent the problem. So I've drawn a picture here. The skateboard's $89.88, and the helmet, which is a terrible picture of a helmet, but that's my helmet, $34.74. So together they would equal, if I add those up, they would equal, hold on a second. So together they would cost $124.62. But she gets a discount of $17.50, so you're going to subtract that from the total. So she is only paying $107.12 for the helmet and the skateboard. If she gives her $60, you're going to subtract that and see how much change she gets. So I'm going to subtract them now. I don't have enough pennies, I don't have enough dimes, I don't have enough dollars to regroup, so I'm regrouping my tens here. Give me 10 ones. I'm going to regroup a 1 and make it 10 tenths, and regroup one of those to make it 10 hundredths. 10 minus 2 is 8. 9 minus 1 is 8. 9 minus 7 is 2. 5 minus 0 is 5. So 1 minus 1 is 0. So the change you should get is $52.88. Now if we look at our estimate says if you spend $160 and all these numbers are rounded, that would be this would be 160 minus 100, so our estimated answer should be close to 60, and you can see that it's pretty close to 60, so our answer is reasonable. Alright, looking at this word problem, let's unpack it. Brian's school, 2 fastest runners in the 100-yard dash had a race time of 12.29 seconds and 12.47 seconds. Remember, the faster time is the time that's less. Estimate and then find how much faster they are. So let's estimate this. Because they're so tight, we're going to estimate it to the nearest tenth. So we always want to, in a number like this, you always want to estimate to a number that's going to make sense. If we estimate it down to the ones place, like here, we'd end up with 0, and that's not going to really help us. So we estimate down to the tenth. We have 4 here. We look to the right, that's 7. That's going to round up to 12.5. And this one here, you have 2 here, 9 next to it, that's going to round up to 12.3. So if you compare those two numbers, 12.5 and 12.3, you end up with a difference of 0.2. We find the actual difference, so on that we're just going to subtract the 2, compare them, and my comparison bar model shows that. So I regroup 1 tenth as 10 hundredths, giving me 8 hundredths. 3 minus 3 tenths minus 2 tenths is 1 tenth. So the actual difference is going to be 0.18 or 18 hundredths, and that is very close to my estimate of 20 hundredths or 2 tenths. So that works out fine. A series of rounding problems for number 26. They're asking us to find out if it is true or false. Is 244 and 6 tenths rounded to the ones place? 245. So look for the ones place, look to the right. You see a 6 there, so yes, that would round up to 245, so that is true. 623 and 14 hundredths rounded to the hundreds place, so make sure you're seeing that as hundreds. I find the hundreds place, look to the right, as a 2, so that would round down to 600. That's the closest hundred, so this answer would be false. The closest hundred to 623 and 14 hundredths is 600. I can tell right off the bat that this one is false here. If you look at it, 1,343 and 4,500 round to the nearest tens place. So if you round this to the tens place, you're not going to get 134. You're going to get 1,340. That number is that is just way too low, so that's false. All right, so 67 and 942 thousandths rounded to the nearest tens place. That's the tens place, so I know this is going to be false because that's not rounded to the tens place, that's rounded to the tenths place. So this number should round up, the nearest 10 is 70, 7 tens. False. And the final one is you're rounding this number to the hundreds place, so that's my hundreds place, look to the right. That's a 3, so you're going to round it down to 219 and 56 hundredths, so that is true. Got a word problem here. Shana takes measurements of rainfall for a week. She measures 2,200 centimeters on Monday, 3,800 centimeters on Tuesday, 14 centimeters on Friday. The rest of the days had no rain. So let's fill in the chart. Monday, 22 hundredths. Tuesday, 38 hundredths. Friday, 14 hundredths. And since there's no rainfall in the rest of the days, Saturday must be a 0. So we're going to add up 22 hundredths, 38 hundredths, and 14 hundredths. Putting those together, you get 1, 2, 3, that's 6, 7, 74 hundredths. So each one of these is 10 hundredths of centimeters. So that's 10, 20, 30, 40, 50, 60. This is not enough. 10, 20, 30, 40, 50, 60, 70, 80. That's too much. 10, 20, 30, 40, 50, 60, 70, 80. That's too much. 10, 20, 30, 40, 50, 60, 70, and 4. So the correct answer would be D. Alright, with all word problems, we want to draw models to match it. We got a lizard's body, so here's my lizard. It looks like a square. I'll put an eye there. And here is a lizard's tail. The lizard's body is 2.65 feet long, and the tail is 1.98 feet long. So they're asking us how long is the total. So we're going to add up 2.65 and 1.8 to get our total, part, whole model. And over here you can see I've done my math. 4.63 would be the feet, would be the total length of the lizard. So that would answer here. Now they're asking us how much longer do they need to go to get to 6 feet. So here, you just add on to that model, what's the difference between 4.63 and 6.0? So comparing these two numbers, regroup. 10 minus 3 is 7, 9 minus 6 is 3, 5 minus 4 is 1, so that lizard needs to grow 1.37 feet to get to 6 feet. Alright, this is a very unusual problem. I remember it from last year, but anyways, let's unpack it. At a yard sale, Ying helped a customer who buys items that cost $4, $3, $2.50, and 25 cents. The customer hands Ying $3 and says, keep the 18 cents change. How much did the customer think the total was? So if the customer gave Ying $3 and thought there was 18 cents change, then they thought that it was going to be $2.82. So think about the problem here. Look at these decimal points. 4, there's a decimal point here. 3, there's a decimal point here. So this customer did not line up the decimal points. It should be 4.00, 3.00, 2.50, and 0.25. So they treated 4 and 3 as 4 cents and 3 cents. So that is incorrect. Simple true or false on this problem, last one, is you're just finding out if that's correct, so just check each one. 7 plus 5 is 2. Regroup the tenths here. 5, 8, and 1 is 14. So this is true. Okay, so you see this here? I almost got stuck on it. 55, that's actually 55.000. So this is going to be false because they did not put the decimal point in the right place. Remember, line up the dots. So this is false. Decimal points are lined up here. 6 and 9 is 5. They did not regroup properly. 6 and 9 hundredths is 15 hundredths. They forgot that 100th there. So it should be 11 here. Regroup that. So they did not regroup properly. This one is also false. And 104 and 5/10 plus 5 and 3/10 is 109 and 8/10, so that one is true. So on this one, just make sure they're lining up the decimal points like they did in here and also regrouping properly. 3 things in human life are important. The first is to be kind, the second is to be kind, and the third is be kind. Good luck studying. You guys will do well. If you need an extra practice test, go ahead and let me know. Email me and I'll get one out to you. And you should be in good shape. You should get an A+.